Yaskawa. This video shows how to commission an MPiec controller and servos using only the project archive within the web server. Here's a quick preview of everything I'll show in this video. Acquire the correct project archive file and send it to the controller. Then send the parameters to the drives, initialize the absolute encoders, and calibrate access positions. Now let's go through this procedure in more detail, as outlined in the MPiec Quick Reference Guide, document number QRG.MP2000 Series.01. The project archive file listing can be seen in the web server. These files contain all the data required to run the controller, including ladder logic, user units, and drive parameters. This data can be saved as a single zip file from one controller and loaded into another. Once the archive is loaded, parameters can be sent to each servo. With parameters in place and encoder faults clear, the machine position can be calibrated. If it's a new controller, remember to first go through the initial steps to apply settings such as the IP address and firmware. For details, see the setup videos and Quick Reference Guide. If it's an existing controller, be sure all motion is stopped. I'm connected to an MP2300 SIEC in this example. This is the off-site video feed of my remote connection to this training demo. Startup from an archive with the other MPiec controllers follows the exact same process. Log into the web server using the login admin with capital A, along with the password that corresponds to your controller. Different controller products use different passwords, and in this case I'm using the MP2300 SIEC, so the password is MP2300S, all caps. Now obtain the correct project archive file. This is a zip file, and it should remain in the zip format, so don't try to extract it. This archive file may have originated from another controller, or it can be created in MotionWorks IEC. Now let's send the archive to the controller. In the web server, go to Project Archive and browse to the directory containing the project archive file. Choose Clean Install, which will first delete any previous archive files from the controller, and then click to send to the controller, and OK to confirm. The button now reads Wait and is grayed out for about 1 minute while the archive is sent. When complete, the archive file listing will appear, including the Access Drive PN XML files. As mentioned in the note, sending this archive does not send these parameters to the drives. Sending the drive parameters is done separately for each drive as required in the Drive Parameters page. The Drive Parameters page refers to those archived parameter files as the user parameters. You can verify the current parameters in the drive to the parameters in the archive. I have Axis 1 as a mismatch, but Axis 2 matches. Then you can write only to the mismatched axes, or keep it simple and write the parameters to all the axes at once. The archive and servo parameters are not active until reboot. So let's go to Maintenance, Reboot, and Reboot Controller. OK to confirm. And it takes about 45 seconds to reboot. The controller is rebooted when the ready light turns on. Refresh the web server and check alarm status. If the application uses the absolute encoder feature, you're likely to have encoder alarms on a new installation. This is the time to clear them. The most common absolute encoder alarm is A.810, which appears any time battery power was lost. Initializing the absolute encoder will clear the alarm. Under Machine Operations, you can see which axes have these alarms. But to clear them, go to the Drive PN tab and pull down to select the axis. Use abs encoder init to clear A.810 and multi-turn reset to clear A.cc0. Repeat this operation for all of the affected axes. If you're having trouble with Java on the machine operations page, try lowering the Java security settings. For details and the latest fixes, please search yaskawa.com keyword Java and refer to the FAQ document MTN-9GRTZ5. Now you'll notice that this process did not make the encoder alarms disappear. This is because another reboot is required. So let's go to Maintenance, Reboot, and Reboot Controller. OK to confirm, and wait another 45 seconds for the reboot. And the ready light is turned on. And at this point, the controller, drives, and motors have all been updated, and there should not be any alarms. But there is one final step, which is to zero set or home each axis and perform any other first-time machine setup procedures. Zero set and home sequences are specific to the machine, and they'd often be carried out through the HMI. And it should be mentioned at this point that sending parameters, initializing absolute encoders, and rebooting can all be accomplished through the application program. But if this hasn't been implemented, you can always use the web server as I've shown here. Function blocks associated with the automated startup and maintenance include MC set position, Y write parameters, Y reset absolute encoder, Y reboot controller, which is part of the Y motion firmware library, and absolute position manager, which is part of the PLC Open Toolbox user library. Thanks for watching this video, and remember yaskawa.com/IEC for application notes, videos, firmware updates, and more.